Hey guys, welcome to my next video on investment appraisal. In this video, I will be explaining few basic concepts on investment appraisal like cost of capital, discounting, and present value by calculating basic problems. By fully understanding these basic problems, you can comprehend the more difficult concepts of investment appraisal. So let's do the first one. T0, T0, T1, and T2. You can write down year 1 and year 2 and year 0 as well. So what are they saying? That in T1 I'll receive £100 and to T2 £125. What is the real value or the present value? Okay, from now on I should use the word present value. What is the present value of this money? What we do, we multiply with this. So what we need to know now is that discount factor. So all the values given in the present value are called discount factor. And the cost of capital, okay, let's add at 15%. At 15%, let's go to our present value table. Under 15%, which is here, for 1 year, after 1 year, value of £1 is 0.870, and after 2 years is 0.756. So I will multiply T1 value with that and 756 with this. To bring it to T0, I'll multiply cash flows with discount factors. The value of £1 received after 1 year, if the cost of capital is 15%, is 87 pence, and in £100 is 87 pounds, and value of 125 received under 15% is 94.5 pounds. So this is a situation in developing countries nowadays. We can see the developing countries with higher inflation rates. We have this situation. So the total value we received is this versus 225. So if we take my example, where somebody says, okay, if you give me £200 now, I'll give you £100 in a year time and £125 in 2 years time. Should we do that business? No, because we're actually getting less than £200. The present value of that £225 is only £181.50. So we call it present value, and this is the amount. Don't need this. All right, now the situation is that we are receiving £100 for the next 3 years, 1, 2, and 3. So 100 T3 cash flows. You can call it cash inflows because it's a positive value. To convert it into present value, we will discount factor at 15%. We've just used 0.870, 0.756, and then we look at for year 3, 0.658, present values, and we can add all of these, sum of all these to get the total present value of £228.40. So we can see that we received £300 in total over 3 years time, but the present value of that money is £228.40. There is a quicker way of doing this. And that would be using annuity tables. We looked at the second table, which tells us the values of £1 received consecutively. So our second example is actually that situation. We are receiving £100 consecutively. So what do we do? Rather than doing the long way, we can actually multiply. We are receiving 100. We can multiply this with value of £1 received for 3 years consecutively under 15%. So if you multiply this, our annuity factor for £1 received for 3 years is 2.283. And this gives us an answer which is very similar to the one, and the difference is because of the rounding off. So we will ignore the difference. It's actually the same result from the calculation point of view. So whenever you receive an annuity, you look at the annuity table, multiply the value with the factor, and you get your answer. But to use this, you have to have same amount being received every year. If you're receiving different amounts or paying different amounts every year, then you have to use the present value table, not annuity table. Slightly more complicated now. We are receiving £100 at T2, T3, and T4. So nothing at T0. But T4. Yeah. So the present value should be £100 multiplied with. So let's look at annuity table, because we are receiving the same amount every year. 15% for 4 years, we get 2.855. So we multiply that with 2.855. However, we skipped year 1. Yes. So because we skipped year 1, we would take away the annuity factor for year 1. If we would have skipped year 1 and 2, then we would have taken away 1.626. But in this case, minus 0.870, just that one, and we will get our answer. $198.5. You can see that the timing of the cash flows is making a massive difference. If you receive £300 in year 1, 2, and 3, you're receiving £228.40. However, you receive the same £300 in year 2, 3, and 4. The present value is £198.50. So a significant difference. Point number 4 is that you start receiving £100 starting at T1 in perpetual. £100 starting. Simply divide that with the cost of capital. in percentage, not in percentage, but in decimals. So you're receiving £100 divided by 15% is the cost of capital. So whatever the cost of capital is, divided by that. So the value of £100 received forever is £666. And you would be wondering, how is that possible? Because if you receive £100 for 7 years, it's equal to 700. So within 700, you actually exceed this value. But the fact is that higher the cost of capital is and the higher the time period, the furthest you go, the money loses value more. If you have a very unpredictable future, you would not agree with any money in comparison to what you're getting now. So going back to our example of £100 now or £200 in 5 years time or 10 years time, if the risk is too high, you would not accept any money for 100 now. So somebody says, I give you 1,000 in 10 years time. You would not give any value to that because you know that that 10,000 may never happen. Or maybe £1,000,000 in 20 years time. You need £100 now. You would take that. Now, making it a bit more interesting. So £100 received, number 5, it's growing at 5%. D naught, P naught equals, and P naught is the present value, D naught equals 1 plus G divided by KE minus G. Okay. KE is cost of capital. So in this case, we have £100 and 1 plus G is growth rate, 0.05. 5% is 0.05 divided by 0.15 minus 0.05. And if you solve this equation, you would actually find out your answer. 100 times 1.05, 1050, and £1,050. So £100 received forever, growing by 5% every year. The present value of that is 1,050. This is very, very useful, especially for your assets, for example. So if investors have an asset and that asset is generating, let's say, £1,000 every year or every month, let's say £12,000 or £10,000 every year, and they get an offer from another party that they're willing to buy that, this can actually help them to decide should they sell that asset or not. So because this is currently the present value is, so I have, let's say I have any asset and it's giving me £100 or £1,000. Obviously all we have to do is increase zeros. So if it's getting 1,000, then it's 10,500. If it's 10,000, is 105,000. Yeah. So any asset is making me £100 a year and is growing by 5%. And somebody says, I am willing to give you £1,000 now, obviously it's a bad deal. Yeah, 1,050 is the right thing. But whenever you sell something profitable, you always charge a premium. You're not going to sell something which is in your possession and is giving you 150, and then you actually sell it and get exactly the same amount. It's not going to happen. You will charge a premium. This is the minimum amount you would accept, though. Or if you are in desperation, then you might sell it for that value, or maybe a little less as well. But that is the present value of that asset, and you can sell. So many people, when they sell their businesses, they use this method, and this method is called cash flow valuation method. Okay, next one. So slightly different situation. We have T1. We are receiving 10 pence, 12 pence, and then 11 pence. And then we are receiving T4, we're receiving 11 pence plus 3% extra. So the timeline is T0, T1, T2, T3, and T4. So we are receiving 10 pence. It could be pounds as well. 11 pence. No, 12 pence. 11 pence. And then 11 pence plus 3%. I know it's not very clear that in year 4 you're getting 11 pence plus 3%, but that's what it is. What you do, you multiply these values with the discount factor 0.870, 0.756, 0.658, and then you apply the same formula which you have applied here in this place. So 11 into 1.03 divided by 0.15 minus 0.03. Applying my formula, $94. The interesting thing is that when you apply okay, so what do I have? 9.072 and 7.238. When you apply this formula, what we did, we applied this formula at T1 and it gave us the value at T0. So this formula brings the cash flows 1 year back. So when you apply it at T4, it actually would give you the answer at 94.42 at T3. Now to bring it from T3 to T0, we're going to have to multiply this with 0.658 to get the value at T0. 62.13. So to get the PV, you add 8.7, 9.072 plus 7.238 plus 62.13. $87.14.